Thank you for joining us for this webinar. My name is John Wagle. I am the SAFER Regional Manager for Industrial Scientific, and today we'd like to discuss how you can build an emergency toolkit and deploy it in an emergency to hopefully both protect human life and safety, and also get your facility back up and running as soon as possible following an incident. This is my contact information. Please don't hesitate to reach out if you have any comments or concern or need follow-up on anything we talk about today. I like to start this presentation by sort of covering why we do what we do. These are three major incidents that happened over the years, and in each of these cases, there was kind of a recurring theme. When the emergency itself started, the employees at the facility simply didn't know exactly what they should be doing, where they should go, who they should be talking to, what they should be responding to, and that caused further problems. Those problems themselves spun off into separate issues, and before anybody knew it, a full-blown crisis had broken out. In all three of these cases, had there been an emergency toolkit in place, the actual breadth of the incident could have been mitigated and human life could have been protected, as well as financial interest of the refineries in question. Industrial Scientific has the vision of eliminating death on the job by the year 2050, and our mission is to preserve human life on, above, and below the earth. We're going to accomplish that by delivering the highest quality and best customer service every transaction, every time. As I mentioned, the topic for today's webinar is how to build an emergency toolkit. We'll break that down into 4 key points. Number 1, the rationale behind this, why you need an emergency toolkit. Number 2, what goes into an emergency toolkit. Number 3, how we can plan with our toolkit and get it set up so that we can deploy it during an emergency. And finally, how to actually deploy the toolkit during an emergency. This slide shows issues that have been reported by our clients, concerns they have about their facility, their plant, their refinery, what have you, that have risen up over the years and, for lack of a better term, keeps them up at night. The first category is emergency response and preparedness. They are rare, but during a high pressure situation where lives are at risk, it can become very difficult to coordinate with emergency response and sort of speak the same language, be on the same page. This is further compounded by the fact that the real-time emergency response is a constantly evolving process, which means as soon as you receive information, it's out of date and has to be acted on. Gaps in communication is another core problem. Where are my people? Where are my devices? Different conditions as they change. Where are the different locations on my facility? And information and more difficult communication can sort of cause this feedback loop of just overwhelming the people who are trying to respond to an emergency. Inefficient operations are another key concern. Preparation can take time, and a lot of times it's hard to find experienced staff who can train the newer staff in the proper procedures. The data landscape is also a major concern. Equipment, people, and plants are constantly producing reams of data. How can we understand that, and how can we make that valuable? And we're seeing sort of a phase change in the industry where people are starting to say, what can I do with all of this data? And they're getting very interesting results. And finally, compliance and reporting. Administrative tracking and reporting takes time away from other important tasks. And the data all exists out there, but compiling it and making sense of it is a major concern. So in light of the previous slide, I'd like to just show the hierarchy of safety control, something I'm sure we're all rather familiar with. At the bottom is PPE, and sort of ironically, this is where everyone tends to spend the most amount of time and money. However, it's also the least effective. The reason for this is PPE, by definition, can only start working once something has already gone wrong. Administrative controls are a way for us to improve upon that and increase the effectiveness of our safety program by changing the way people work. Things like equipment as a service, training, Internet of Things, and data analytics all works to help us keep people out of hazardous situations so they never need to use their PPE. Engineering controls help us isolate people from the hazard. This can be accomplished with pre-planning, data science modeling, and AI. And Industrial Scientific sort of positions our products in this order. At the foundation, we make industry-leading gas detectors that have, through the last 30 years, been proven time and time again to be the top of the line, best-in-class gas detectors. However, by wrapping iNet control and iNet exchange around that, we can use that, turn that into equipment as a service. And so now, rather than not knowing where our gas detectors are, the last time they were calibrated and bumped, we know by default. We can then wrap iNet Now and Safer around that. That will enable us to start pre-planning and use data science modeling to understand our facility and control an emergency when it happens. So detection and protection, the first bullet point there is where the PPE kicks in, and we can go all the way up to modeling and mitigating the issue with the chemical emergency toolkit, thus giving us a much better perspective on an emergency, not only while it's happening, but before it happens. To put this in perspective, a study done by the IHCE Spring Meeting and Global Congress on Process Safety found that an average size refinery is going to lose $52,000 per hour it's shut down. QHSE and labor is an additional $30,000 per hour, which gives us the average 4-hour shutdown costing $330,000 in lost work hours and revenue. That's not even taking into account fines and fallout from regulatory bodies, the damage that we can do to our social operating license, or possible OSHA incidents in which someone gets hurt and now needs medical attention. All of those are obviously a huge cost, but simply lost time can cost $330,000 for a 4-hour shutdown. If we take the steps to prepare in advance with the chemical emergency toolkit, we can deflect that curve up. So by understanding the event before it happens, we're able to position our people properly, understand what needs to be done and who should be doing what. And so when an event occurs, it's less a matter of figuring out what just happened and how we can fix it, but simply sliding into the pre-plan that we already have in place thanks to our chemical emergency toolkit. We can prepare by establishing our most likely worst case scenarios in advance, and we can work in conjunction with process controls to ensure that when an event happens, we're responding to the best of our ability. We can optimize our response by providing a common operating picture during an emergency and rapidly responding to incidents. And we can protect by deflecting that curve up. Not only are we protecting revenue, but we're protecting human health and shortening our post-incident recovery time. This is a very interesting slide as well. A survey done back in 2018 found that 10% of residents living near chemical facilities have been trained or educated on how to respond to a chemical accident. Only 30% of residents believe the facility operator has taken the proper actions against chemical accidents in the past. What this means is when a facility issues a shelter-in-place order, there's a chance that 90% of people don't know what to do. They don't know what a shelter-in-place order means. Part of a chemical emergency toolkit is involving the community and working on this. But really, the point we're trying to get to here is your workers and community are counting on you when an emergency happens to take the best possible corrective action and keep them safe. And a chemical emergency toolkit is a way to do that. Now that we've covered why we should deploy a chemical emergency toolkit, let's actually dig into the different components that compose it in order to better understand the landscape. I mentioned PPE earlier. While it is the least effective and where we spend the most money, it's also absolutely critical. You can't skip gas detection. You can't skip steel toes. You can't skip hard hats. You simply need them. They are an absolute requirement for any chemical plant or refinery or any hazardous gas situation. Portable gas detection equipment allows us to detect local hazards, protect our workers, make entry decisions, especially in confined space, and identify responder locations if it's a connected safety device. Real-time weather data is another critical concern for a chemical emergency toolkit. During a chemical spill, conditions can and will change rapidly, and what we need to do is establish resource deployment zones as soon as possible. relying on data from 15 minutes ago or a windsock that's sitting outside the window is simply irresponsible. We really do need the absolute best possible real-time weather data as it comes in. By knowing the current conditions and previous conditions, we can pinpoint areas of concern downwind and coordinate with emergency response to make sure that those areas are protected. Another incredibly value aspect to a chemical emergency toolkit is connected area monitoring equipment. This is equipment that can be moved around independently and functions as a gas detection device without having to have a person there. This, for the very first time, if we can actually deploy something like the radius unit, that's the orange traffic cone looking thing in the middle there, by deploying a radius unit, our system for the very first time is now moving from reactive, in other words, we have a gas detection clip that is going off, to predictive. We understand that an area is being exposed to a hazardous gas before we make an entry decision. This also allows us to cover multi-threat detection. Typically, these are 4-gas or 6-gas systems. We can establish hazard perimeters. We can do long-term hazard monitoring, and we can remotely monitor critical receptors and downwind locations. This is really important because, as I mentioned, you have changing conditions during an event, and all of these are very easy to rapidly redeploy. Grab it by the handle, move it where you need it, and walk away. Because it's a connected safety device, these are all pumping data back into our central command, and we understand areas that are being exposed to hazardous gas. Finally, dynamic plume modeling is another critical consideration in the chemical emergency toolkit. Dynamic plume modeling allows us to quickly calculate chemical release rates and pinpoint the leak source. We can establish control by understanding how current conditions are affecting response teams and areas of concern. We can also automatically update with real-time data, and we can guide our actions based on real-time automatically entered data. The system shown here is SAFER, Systematic Approach for Emergency Readiness, which is an industrial scientific product that allows us to model a plume not only in real time based on real-time weather data and our known release rates, but also historically, so we can understand previous events and develop better plans in the future for them. SAFER also enables us to generate a common operating picture. We can establish an event view that provides an entire picture of an incident from start to finish, where the hazard is, where our monitors are, where our personnel is, including changing wind conditions, real-time traffic, and points of interest. We can then establish our critical receptor locations and ensure monitoring takes place. So with those core components in place, PPE, well-maintained gas detection, SAFER, and a radius unit, here's how we can start to put all of those pieces together and properly set up the toolkit for use. The first thing is to absolutely acknowledge and understand hazards at a facility. And this is kind of a, to be honest, long, hard look in the mirror kind of moment. You do really have to understand what the worst case scenario is, and number one, how you can avoid it, but also number two, how you can respond if it does happen. This is accomplished by characterizing the hazards at our facility and as well as in operations, loading and unloading from a dock. There's a much higher probability of spill there, turnaround and the probability of something going wrong, all of that. And we can add that to our dynamic dispersion model. This allows us to understand the consequence and the hazard. We can review this annually or semi-annually, depending on how we need to. And by practicing it weekly, we start to drill it into the heads of everyone. This is what I need to do during an emergency. Points of interest are offsite locations or on-site locations that are especially of concern. Stuff like hospitals, schools, public venues, public receptors nearby, and muster points. There's sort of a fallacy in a lot of safety-minded industries where the muster point is somehow always going to be safe. It will always be protected and it is sacrosanct. And that is simply not the case. Another sort of interesting example of this where pre-planning is critical is gates and ingress locations. There was a client in Texas who was running various drills and they were testing their worst case scenario. And as part of the drill, they actually called emergency services and said, hey, we're running a drill, but we're pretending that we had a spill of HF in this amount. Can you send an ambulance and a fire truck? And the emergency response 911 did. During the drill, they simulated the plume in Safer and discovered that the emergency response team was actually responding through the plume. Because they had built everything into their common operating picture and identified the key interests and sites, they were able to recognize a completely previously unknown hazard and account for it in the future. So in the future, when they call 911, they are coordinating with the fire and emergency ambulance the entire way to make sure that they're protected as well during their response. Which rolls into point 3. That's why we need to establish a communication plan with local responders and local emergency planning committees. And finally, as I mentioned before, try to take part in educating the community about response procedures. Not only by hearing the community out will this improve your credibility and sort of renew your social operating license, but it will protect them in case of an emergency. So when that shelter in place order goes out, people know what to do. And practice, practice, practice. There's sort of an old saying when it comes to practicing that I like to talk about here. Panic is when the human mind reaches for a memory to help it during an emergency and can't find it. It's sort of a truism, but this principle is used in professional sports teams. They do visualization exercises. This is why an NBA team will practice three free throws over and over and over and over and over and over again. Because when it comes time to actually do it, they have a memory of doing it in practice. And so when you start to panic, you can reach for a memory. And if you've practiced it enough, use that memory to guide you through the emergency. Number one, when it comes to training, is you have to understand your equipment. What does it mean when it beeps? What does it mean when it beeps 3 times? Who will actually see this data? How do I know what's safe or what harmful is? What is the concentration of the gases on site that are lethal? Stuff like that is critical. And again, it's very easy to forget this stuff during an emergency. The more you've practiced it, the more your brain has to rely on during the emergency to move forwards. You also need to know how to use a dispersion model and work through it in a scenario in the case of Safer. I'll show you guys an example of that in the demo portion of this webinar. And tabletop exercises are invaluable. I mentioned the emergency response example earlier. That happened during a tabletop exercise. The more you can understand what's happening and how you'll respond to it, the better your response will be during an actual event. Small drills and large drills are also critical. We need to practice equipment deployment and remote monitoring, as well as create full-scale drills involving multiple departments. So we've discussed why a chemical emergency toolkit, both from a revenue perspective and from a human health perspective, is a good idea. We broke the components down, the PPE layer, the INET protective layer to make sure the equipment's functioning properly, and the safer layer to ensure that we understand not only what could happen, but what is currently happening. Let's finally talk about how to actually deploy the toolkit during an emergency. There's sort of a time frame of an incident from the moment it happens to when it's finally under control. And we'll start at the very beginning when an incident is first identified. During this phase, these are the critical steps that we need to use our toolkit with to ensure proper response. Number one, we have to understand our personnel exposure. If someone has been exposed, what can we do? How can we help them? As well as what detection systems are at our plant. We can then establish wind speed and direction to start to model this chemical emergency. From there, we can make our best determination of scale. This is critical. Basically, during the first 5-10 minutes of an incident, if we can establish where it's coming from, point 1, and point 2, how serious it is, we can then very quickly establish an isolation zone and come up with our protective action distance to ensure our response is on key. From there, we also can identify downwind receptors and unsafe muster points and make notifications if necessary, and incorporate all of this information into our plan going forwards. So in the previous step, we knew something had happened. By the time we hit this step, we know what the hazard is. If we have multiple chemicals we're storing on site, we've determined, oh, this is the chemical in question. Here's how it spreads, and here's how the impact will work on human life health. From there, we can run our first time real-time dispersion model using our predefined scenarios that we've been practicing. We can deploy area monitors like the radius unit, which are capable of intercepting the hazard downwind. And we can establish safe locations, our affected receptors, and incident command locations as necessary. We can then notify mutual aid agencies and communicate potential community impact intelligently for the first time because we have this toolkit in place and we effectively already know what's going to happen during the course of this incident. Once our radius units or whatever detectors we've deployed start providing data, we can use our dynamic dispersion model to confirm the leak location and immediately determine the release rate and calculate impact. Again, I'll show you guys how to do that during the demo portion, as well as monitoring wind shifts to verify impacted points of interest and move our gas detectors as needed. This information is critical because our plan during the emergency is going to be constantly evolving, and we have to be able to respond to it in real time because the emergency is unfolding in real time. And this is how we scale our emergency. So we started in the immediate information, which is effectively something has happened. We then determined our hazard and how we can respond to it, as well as our detectors. This is the hard part because at a certain point, the wind is going to shift or the nature of the emergency is going to change, and we have to jump back to the first step. We have to identify what's impacted now that the wind has shifted and our weather conditions are different, how we're going to respond, who's affected, and work our way through the system. Because the emergency is unfolding in real time, we have to respond in real time. And that's why something like the radius unit combined with PPE, combined with INET, combined with SAFER allows us for the first time to actually treat an incident as it needs to be, like a real-time unfolding thing that we can respond to in real time. In order to continuously improve this process, we should try to use it every day, as well as expand our common operating picture. We can accomplish this with fixed detection or perimeter monitoring, open path and lightning detection. A connected safety ecosystem is always very valuable, and we can drive collaboration and information sharing, as well as performing historical analysis. This is sort of a rehash of a previous graphic we saw, but once we have our personal monitoring in place in our chemical emergency toolkit, we can then wrap area monitoring around that. And this will improve the efficiency of our system greatly, because for the first time, instead of a purely reactive system with personal monitoring, area monitoring allows us to be proactive and see areas that have hazards before a human being has to step into them. Various dashboards, INET and SAFER are great examples of this. Allows us to see the event unfold in real time. And finally, we can wrap our dynamic plume modeling software, SAFER, around that to ensure that we not only understand at the very base level that our people are protected, but also what is happening in real time with the plume for our chemical emergency. SAFER 1 is our dynamic plume modeling software. It allows us to quickly identify a leak source and its severity. We can also predict the path and concentration of a hazard in real time, understand when to evacuate, and operate with confidence. So with SAFER sitting on top of our chemical emergency toolkit, we're now incorporating all available data into a single package that allows us to not only understand all the different hypothetical scenarios that could be happening, but what is unfolding in real time and how we can respond to it. Thank you very much for your time on today's webinar.